I'm very unorganized. All right. So here we go. We want to talk about circles. Equation for a circle is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. It looks bad. It's really quite nice. It's not bad at all. Okay. Now, this is right before section 1.9 in your notes. The center is equal to hk for that circle, and then the radius is r. So let's try to get a point of reference. Anybody understand where this came from? I mentioned it before. Pythagorean theorem, very good. A squared plus b squared is c squared. See it? So if you think about it, a circle, let's say that, this was our circle. You plot the center and then you move a certain number of units according to the radius in each direction. You draw it. Well, if you think about it, if you make a point on the circle from the radius, all you do is you just use the Pythagorean theorem to be able to find the distance from the center to the outside, right? So that's all a circle is. It's just an equation using the Pythagorean theorem. If the circle has center 0, 0, then we plug in 0 for h and 0 for k, and we get x minus 0 quantity squared plus y minus 0 quantity squared is equal to r squared. And what is x minus 0? X. We get x squared plus y squared is equal to r squared. And obviously that looks very similar to the Pythagorean theorem, right? Okay, and that is the fundamental basis for which all of trigonometry is based off of. So write an equation for a circle with the following properties. Center of -3, +2, and radius of 4. What you have to be careful with is in these circles, if you look, the center is h, not -h. So if it was x minus 3, the x value for the center would be 3. If it was x plus 2, then the center would be -2. See the difference? So we're going to write an equation, and if you just plug this in for h and plug this in for k and plug this in for r, you get x minus a -3 quantity squared plus y minus 2 quantity squared is equal to 4 squared. Now you don't have to write out that step. You can see that because you're subtracting a negative, you'll rewrite this as x plus 3 quantity squared plus y minus 2 quantity squared is equal to 16. And yes, you should always square the number on the end. So let's apply our learning and try to understand a little bit better. If we've got a center of 0 and -5, what will the x component be? What will that look like? Just x squared plus, and then what will the y component look like? Y plus 5. Very good. 20 squared is equal to, and since the radius is 1/2, square half, and you get a fourth. What mistake might people make when they square a half? They might come up with 1. Yep, 1 would be the most common answer people would get. Okay, what if the center is 3, 0? What is the x component? X minus 3 quantity squared plus, how about the y component? Is equal to, now we got to square 3 roots of 2. So if you square 3 roots of 2, you've got 3 squared is 9, and the root of 2 squared is, so 9 times 2 is 18, so you get 18. So if I ask you a question like that on your test, can you get that? Okay. Now let's look at the second part, which is examine the equation and identify the center and the radius. Center, radius. What's the center for the first one? 3, -2. And the radius? 4. Any questions how I came up with 3, -2? Any confusion why the positive and negatives behave the way that they do? Okay, how about B? What's the center for B? And the radius? Yeah, root of 48, which you reduce to 4 roots of 3. You have the square root of 16 times the square root of 3 is the square root of 48. Good. Okay, flip it over. All right, we have three problems, A, B, and then example 8. It says, show that the following equations represent circles by placing them in standard form. Standard form is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, let me just be clear. If you have, say, x squared plus y plus 1 quantity squared is equal to 25, there's another way you could write that. You could write that as x squared plus y squared plus 2y plus 1 is equal to 25, right? So why do you think we like to write it the first way as opposed to the second way? Shorter, why else? You can identify the, yeah, h and k and the radius, right? I mean, it's hard to look at this and tell exactly what the radius is and what the center is. So we want to take this and put it into standard form so we can easily identify the center and the radius. You're going to use this skill throughout the rest of the year, not just here. This is your first introduction to it. Fortunately, you already know how to do the skill, and as we are going to complete the square. Process goes like this. We gather the x's, and we gather the y's. We put everything else on the right-hand side. So I've maintained equality in that equation, correct? I haven't changed anything. Just relocated some things, kind of grouped some stuff together. What number would you add to the x's to complete the square? How do we complete the square? We take this number, we divide it by 2, and then we square it to get 16. If I add 16 to the left, add it to the right. I got y squared minus 12y, so what should I add there? 36, so add it to the other side as well. Any questions how I came up with those two numbers? Yes. So this is a perfect square trinomial. I take the middle term, I divide it by 2 to get 4, I square it to get 16. 12 divided by 2 is 6, squared is 36. Now it will factor into a perfect square. That's what we're trying to do because this is a perfect square. This is x minus 4 times x minus 4, which is x minus 4 quantity squared, plus y minus 6 quantity squared equals 59. Positive 59 is what it equals. You're right that the radius is then the square root of 59. So the center will be what? 4, 6, and then the radius is the square root of 59, which we cannot simplify. It is a prime number. Oh, you don't know about prime numbers. You think you know, don't you? Get that tonight. All right, step on up. So, prime number. All right, here we go. We got x squared, and I don't have anything else to group with the x's, do I? Got plus y squared minus 6y equals 7. What number do you, I don't complete the square here, but I do here. What do you add a complete square here? So x squared plus y what? Minus 3 quantity squared is equal to? So my center is, and my radius is, oops, sorry. I was looking ahead in the problem. That's what happens. There we go. Thank you. All right, last example. Find an equation for a circle whose center is -1, 2, and passes through the point 7, -13. In order to identify an equation for a circle, we just need the center, which in this case is -1, 2, but then we also need the radius. Does anybody have an idea how I could compute the radius given that information? Find the distance between the 2 points. If its center is here and it passes through a point there, simply find the distance using the distance formula, correct? And the distance formula says the square root of What's the difference in the y's? How far is it from 2 to negative 13? Not negative 1, but negative 15, right? Or 15 units, right? So we got 15 squared plus, what's the distance from negative 1 to 7? 8, so 8 squared. So we get the square root of 225 plus 64, or the square root of 289, which is 17. Is that enough information to now write an equation for a circle? X plus 1, quantity squared, y minus 2, quantity squared, is equal to 289. That's it.